All right, good morning, everybody. Today, we're going to move on to the next section in Chapter 3, analyzing graphs of quadratic functions. What we're going to look at here are, we're going to analyze graphs in two forms. Two forms of quadratic functions. The first form is called the standard form. That's f of x equals ax squared plus bx plus c. Remember, a, b, and c are simply numbers. They're not associated with x. Oops. So whatever the coefficients, a, b, and c are simply coefficients or constant. And the second form is called the vertex form. And that looks like that. And we'll get to discussing why I call it the vertex form. So let's first begin with the standard form. Well, to graph a quadratic function, we need the vertex of the graph. The vertex is the highest or lowest point on the graph. We need to know the x-intercepts. Where the graph crosses the x-axis. These are also called solutions or zeros. The third thing we need is the y-intercept. Where the graph crosses the y-axis. Now, well, an x-intercepts, we can have 2, 1, or 0 real solutions or intercepts. Because the graph could look like this, could look like this, or it could look like this. We have 2 solutions, only 1, and no real solutions. but each function has to have a y-intercept because of the end behavior of both arms of a quadratic equation. It has to cross the y-axis some point in space. Reflection point of the y-intercept. If here's our vertex down there, then the same distance from the vertex to that point, we should be able to go the same distance the other direction and find a mirror image. It's reflective about what's called the axis of symmetry, which is the fifth thing we'll find. So with both of the forms, the standard form and the vertex form, we'll find all these. But then once you do that, plot the points and connect the dots. We'll also know by looking at the equation, we'll know the direction of the curve, whether the arms are pointing up or pointing down, and if it's going to be wide or skinny. The shape and direction of the graph are given by the value of A. A is called the leading coefficient. So in our two forms, this A and this A will tell us the shape and the direction of the curve. And we'll learn how to go from the standard form to the vertex form, or from the vertex form to the standard form. We can transfer them both ways equally. All right. So let's look at this. Here's some examples. Let's start off with an example. Example 1. X squared plus 10x plus 23. I'm going to ask you to graph this one. Remember, we want to know the vertex. We want to know the x-intercepts. We want to know the y-intercept. We want to know another point related to the y-intercept. And direction and shape of a graph. And the axis of symmetry. So we're in standard form. Just by looking at this, we can answer this one and that one, just by looking at the equation. Number 3, the y-intercept is always the constant. Remember, to find the y-intercept, set all your x's equal to 0 and solve for y. So if we make all our x's 0, that's gone. So what we have left is 23. So our y-intercept is at 0, 23. The direction and shape. Remember, for our direction and shape, we have to look at the a term. Remember, our function actually looks like this, where a is positive 1, b is positive 10, and c is positive 23. So the direction. If a is positive, the graph opens up. Well, I forgot to ask you, how do we know this is a quadratic equation? It's a quadratic equation because the highest exponent is 2. That's a quadratic equation. It's a quadratic equation because the highest exponent is 2. And so the leading term tells us what we need to know about the shape and direction. If our leading coefficient is negative, the graph opens down. Again, we learned that in end of chapter 2, we did transformations. For the shape, if the absolute value of a is bigger than 1, the graph is vertically stretched. It's very skinny. If the absolute value of a, if the absolute value of the leading coefficient is 1, or greater than 1, then it's tall and skinny. If the absolute value of a is between 0 and 1, then it's squashed. It's wide. So in ours, since a is 1, that's greater than 0, so it opens up. And since it's equal to 1, it's just a standard quadratic equation. It has that shape. So we just looked at 2 of the 6 possibilities. All right. So the next one, let's look at the vertex. If in standard form, the vertex is found by using the following equation or formula. If in standard form, remember, if you're in y equals ax squared plus bx plus c, the vertex, the x value, so it's a point, the vertex is a point. So the vertex will have to have an x component and a y component. The x component is found with that formula. So x is equal to negative b over 2a. That's why you label a, b, and c to begin with. Once you find that value, plug it inside the original equation. So the y value is whatever that x is, you plug it back into the original equation, and there's your vertex. If in vertex form, the vertex is simply this, HK. Remember, the vertex form looks like this. Where H and K are H and K. Remember, I always come to whenever you're inside the parenthesis with the X's, it's always the opposite. If it's a minus H, then it's a positive H. If it's an X plus H, it's a negative H. And then the K is what the K is. That's all it is. That's why in the vertex form, that's why I call it the vertex form, because it gives you the vertex. So in our case, in our example, our A was 1, B was 10, and C was 23. So B is 10, so it's negative 10. 2 times A is 1. So it's negative 10 over 2, which is negative 5. So we plug in negative 5 into the equation, x squared plus 10x plus 23. So we got negative 5 squared plus 10 times negative 5 plus 23. Negative 5 squared is 25. Positive times negative is negative. 10 times 5 is 50. Plus 23. 25 plus 23 is 48. Minus 50 is negative 2. Because 50 is bigger than 48 and it's negative. So that's our vertex. When we find the vertex, we also found number 6. Because remember, the axis of symmetry is through the vertex. The axis of symmetry is through the x value of the vertex. So that is your axis of symmetry. The axis of symmetry equals the x value of the vertex. Okay, so now since we know the vertex, let's pretend we're drawing a graph here. The vertex is at -5 and down 2. So there's a vertex. A is 1, so it opens up like this. -5, -2. We know the y-intercept is at 23. Since the y-intercept is a point, how is it situated from the vertex? It's 5 to the right and all the way up to y equals 23. So it's up 23, 24, 25 spaces. So we can go the other direction. 1, 2, 3, 4, 5 to -10 now and go up 23 spaces. And there's our second point. That's why they call it the axis of symmetry. Whatever point is to one side of it, it's the mirror image on the other side of that line. It's 5 spaces in either direction. And it's up from -2 to 23 is 25 spaces from the vertex. So we've automatically found 3 points. With the hardest math we did was this fraction and plugging it in. So that was step number 4, finding another point. So think about it. What have we done so far? Out of those 6 things we had to do, we found the vertex, check. We found the y-intercept, check. We found another point. We found the direction and the shape of the curve, and we found the axis of symmetry. Only thing we haven't done yet are the x-intercepts. That's the part that takes the longest. So let's find, so we know the shape. Only thing we have to do now is find these 2 points over here. Let's do that. Step 2. To find the x-intercepts, or solutions, or what they're called zeros. To find the x-intercepts, to solve a quadratic equation, We have three methods, and we're going to cover all three of them. We're going to find it by factoring. Factoring is taking a large equation and breaking it down to smaller and more simple equations. That's going to be the first one. Actually, that's going to take the longest. The next way we're going to do is called complete the square. This is a process that works best when your b value is even. Even if it's not an even, if the b value is odd or a fraction, if b value is even and an integer. Even if it's not an even value or integer, you can still find it. You just have to deal with fractions now. And the last method that will always work is a quadratic formula. And typically in my classes, I go ahead and show you how I go from standard form using complete the square. We get to the quadratic formula. But I'll put that as a separate video so you can watch it if you want to. The reason I show that is because you don't have to memorize the quadratic formula. All you have to do is know how to complete the square. And that's a simple series of steps. This method always works but you have lots of steps. You have to be good in basic algebra. All right. So let's begin. Let's look at factoring. To show you factoring, I'm going to start off with what's called reverse engineering. I'm going to give you the answer, and then we're going to work our way backwards. These equations have the same numbers, same letters. Only thing different between them are their signs. So they're all x, 2 and 3. So it's plus 2 plus 3, plus 2 minus 3, minus 2 plus 3, minus 2 minus 3. Here you have to be able to be comfortable with multiplying two equations by distributivity. Yes. They call this FOIL technique in high school. It is a FOIL technique, but if you memorize a FOIL technique, that's only works when you have what are called binomials. These are called binomials. Why are they called binomials? Only has two terms. So we have two terms here and two terms here. When we multiply them together, how many terms will we have? If we have two terms here and two terms here, 2 times 2 is 4. We should have 4 terms when we first multiply them. Let's do this. Distributivity says whatever's in front, whatever's in front of the second parenthesis, everything inside here has to multiply to everything inside here. So let's start with the x. X times x is x squared. Then positive times positive is positive. X times 3 is 3x. Positive times positive is positive. 2 times x is 2x. Whenever you have coefficients, the numbers always go in front. Positive times positive is positive. 2 times 3 is 6. There are our 4 terms. Whenever you get rid of parentheses, the first thing you should do is combine like terms. So here we have 2 terms that are the same. So we combine those. They're both positive, so the answer is positive. Add the numbers. There we have it. We end up with what are called trinomials. It has 3 terms. So we have 2 binomials multiplied together, and after everything's said and done, we end up with a trinomial. And that's the state, that's the form of a quadratic equation. Ax squared plus bx plus c. Let's do the rest of the other 3. X times x is x squared. Positive times negative is negative. X times 3 is 3x. That does it for the x. Positive times positive is positive. 2 times x is 2x. Positive times negative is negative. 2 times 3 is 6. Combine like terms. Negative and positive. Since 3 is bigger and it's negative, the answer is going to be negative. 3 minus 2 is 1. X minus 6. Negative times negative is, x squared. X times x is x squared. Positive times positive is positive. X times 3 is 3x. Negative times positive is negative. 2 times x is 2x. Negative times positive is negative. 2 times 3 is 6. Combine like terms, we get x squared, opposite signs. 3 is bigger, so the answer is going to be negative. 3 minus 2 is 1x minus 6. And the last one, x times x is x squared. Positive times negative is negative. X times 3 is 3x. That does it for that one. Negative times positive is negative. 2 times x is 2x. Negative times negative is positive. 2 times 3 is 6. Combine like terms. They're both negative, so the answer is negative. Add the numbers. And there we have it. What we just did, going from here to here, that's called distribution or distributivity. That's going from smaller terms to a larger term. We're multiplying together. What we're interested in now is going from the bigger one to more simple ones. That's called factoring. I'm going to start on the next page because I'm going to show you, give you the steps as well. So we'll start off with the first one. We're going to work backwards. Y equals x squared plus 5x plus 6. Actually, factor and solve. Because it is an equation, it's got an equal sign there, it's got x's. Your first step. Set equal to 0. Make your equation equal 0. I'm going to show you, because the first examples we're going to look at, our leading term is 1. And those are straightforward. That's the method I'm going to show you here. It gets a little more complex when the leading term isn't 1. It's like 6 or 8 or 9 or 7 or whatever. So I'm going to show you only one method that'll work for both of them. So once that equals 0, put both of your parentheses down because that's where your answer is going to go. Remember, it's ax squared plus bx plus c equals 0. Put a in both of the first spaces. Put ax, I mean, sorry, it should be ax. So what is a in our example? 1. So we put 1x and 1x. Look at the second sign. This is the second sign. If it is positive, then both signs are the same. And they are the first sign. Since the second sign is a plus, that means both signs are the same. They're whatever the first sign is. Since it's plus, they're both pluses inside of the parentheses. Nope. B. If it is negative, the signs are opposite. One's going to be positive, one's going to be negative. So in your parentheses, you'll have one positive, one negative. the fifth step. Because so far we have the first term, we have the sign, we have to figure out what these numbers are. The fifth step. Multiply the A and C terms, or coefficients. Not that in terms, but values. So multiply A times C will give you some number. I'll call that N right now. Then what you have to do next is, so in our case, we have A is 1 and C is 6. So we have 1 times 6 equals 6. That's what we did in step 5. Now, find two numbers when multiplied equals N, and when second sign equals B. Find two numbers when multiplied equals what we just found here. And then when whatever the second sign, so we have to find two numbers that multiply to equal 6. That in this case, since the second sign is a plus, when we add them, they equal 5. That's the B term. So you look at what makes 6? 1 times 6, 2 times 3, and that's it. So which two added together give us 5? So our answers are 2 and 3. Place those numbers in their appropriate spaces inside the parentheses. So we have, since it's 2 and 3, one of them is 2, one of them is 3. Since they're both positive, it doesn't matter which one. So x plus 2 times x plus 3 equals this. That's the factored form. Now we got to set it equal to 0. Now, using the 0 product principle, solve for x. Okay, the 0 product principle says this. If I have two numbers and I multiply them together and they equal 0, what has to be true? Any number times 0 is 0, right? So either A is equal to 0, B is equal to 0, or they're both equal to 0. And so since we don't know which one's which, we set them both equal to 0 and solve. So what that says is take our two equations and set them both equal to 0 and solve them. Because together, when they multiply, it equals 0. So x equals -2 and x equals -3. These are our x-intercepts. Let's do another one. Let's keep it where we were. X squared minus x minus 6. Since it's equal to 0, we're looking for x. Whenever you see an equal sign of variables, you have to solve for x. The first step, a is 1, so it just have 1x times 1x. Look at the second sign. It's a minus. If it's a minus, then the signs are different. One's positive, one's negative. Third step, take your a term times your c term. Don't worry about the signs, just the numbers. Now we got to figure out what two numbers multiplied give us 6. That when we subtract them, we get 1. So 3 times 2 is 6. 3 minus 2 is 1. So we know they're opposite signs. One's positive, one's negative. But since the second sign is minus, the bigger number gets the first sign. The bigger number gets the first sign because the second sign is minus, which means they're both opposite signs. Now, take them since it's equal to 0. Take both of these equations, set them equal to 0, and solve. And those are your x-intercepts. Remember, all the rules we talk about since the beginning of the semester always apply. So what would be the first thing you do in this example? In this example? Ow. Yeah, so we set it equal to 0 since it's a quadratic equation. We set it equal to 0, and then we get rid of the fraction. Find the LCD. Multiply each term by the LCD. So each term on both sides. So everybody gets a 2 in front of them. Then we reduce. So only fraction we have is this one. Those cancel. So what we have left is 2 times 0, x squared, 2 times 4x, plus 2 times 8. Multiply and solve. 3 times 0 is 0. Negative times positive is negative. 2 times 4 is 8x. 2 times 8 is 16. So we got rid of the fraction. Now let's see. The leading term goes front. That's 1x, 1x. The second sign is a plus. What does that tell us? Yep, they're both the same signs. They're both going to be minus. Very good. If the second sign's a plus, it's going to be the same signs. It's whatever the first sign is. Now multiply a times c. So we have 1 times 16 equals 16. We have to figure out what two numbers multiplied give us 16. When we add them, we get 8. So let's see, what makes up 16? We have 1 times 16, 2 times 8, 4 times 4, and that's it. So which two together add to give you 8? 4 and 4. Since it's equal to 0, set them both equal to 0 and solve. When this happens, we have the same solution. When this happens, since a is positive, it opens up. Our vertex is on the x-axis. Our vertex is on the x-axis. So whenever your solutions are the same, so the axis of symmetry is x equals 4. The vertex is at 4, 0. And the x-intercept, the y-intercept is where? We go back to the original. Remember, at the original, our y-intercept was 8. So we go back to the original. It's not going to be 16 because that's after we massage and everything. It's 8. So we cross at 8 wherever 8 is going to be. And remember, it's going to be wider. Why is it going to be wide? because the original A is 1/2. It's 1/2. It's going to be twice as wide. So we have an intercept at 8. Since we have an x-intercept or y-intercept at 8, which is 4 spaces that way, if we go 4 spaces this way and up 8, we have another point. Remember, because of the axis of symmetry, it mirrors both sides. Okay. The factoring method is fun if it works. Actually, let's see. Here's one where A is not equal to 1. This is an example when A does not equal 1. Set it equal to 0, which means everything's got to be on one side. Put your parentheses. Now we put 6x in both spaces. Since it's a negative, the signs are going to be different. And the bigger solution will get the positive sign. So far, so good? I mean, nothing's changed. We did the same thing we did in the past. So now we take the first and last terms, A times C. So it's 6 times 12 is 72. We got to find two numbers multiplied together give us 72. That when we subtract them, we get 1. The B term. So we begin. 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, 8 times 9, and that's it. All of these multiplied give you 72. This is the hardest part. This is where your multiplication skills have to come in. Yes. One's going to be, because this number times this number equals this number. And the only way it can be negative is if they're opposite signs. Oops. Yeah, I misprint. Thank you. Yeah, that would make it really hard at the end. So we know it's 8 times 9 is 72. 9 minus 8 is 1. So where does the 9 go? In the first or second? It goes first because the first sign's plus. So the bigger number gets the plus. Okay, now we could go ahead and set it equal to 0 and simplify it. But there is one way you can make it even shorter. In this first parenthesis, what do they have in common? What do 6 and 9 have in common? What's that? They both have a 3 in common. 2 times 3 is 6, 3 times 3 is 9. So we could take out a 3. To see what goes inside the parenthesis, I just divide both of these numbers by 3. 6 divided by 3 is 2x. 9 divided by 3 is 3. Do the same thing with the second one. What do they have in common? They're both even, so they have to have a 2 in common. 6 divided by 2, 8 divided by 2. 6 divided by 2 is 3x minus 4. Whatever you factored out, just erase. Get rid of it. There's our factored form. Now we take both of these and set them equal to 0 and solve for x. And hopefully by now everybody knows how to do that, so I'm not going to show you step by step. Move the 3 over, divide by 2. Move the 4 over, divide by 3. These are your x-intercepts, your solutions. It's just, that's why I try to show you only one method that works for both, depending on what A is. So it doesn't matter now, it's just the same steps. What if the equation is non-factorable? I don't know if that's a word, but I'm using it. What if you can't factor it? Basically, I know that's what I'm trying to say. If you can't factor it, in other words, if I gave you this example, because what times what is 23? When you add them, you get 10. That's a prime number. Yeah, you can't. So there's no factor. So we have to use another method. This is where we're going to learn how to do complete the square. First up, set it equal to 0. When you do that, everything's got to be on one side. If A does not equal 1, then divide each term by A. If it does equal 1, then let's move on. So A is 1, so we're good. We don't have to divide anything. Third step, move the C term, the constant term, to the other side. We do that by subtracting 23 from both sides. So we get negative 23. I mean, so far it just seems pretty straightforward. There's nothing really magical we did here. We set it equals 0, so everything has to be on one side. We made sure the leading coefficient is 1. So we have x's on one side, non-x's on the other side. Now, add b over 2 squared to both sides. So what is our B term? Remember, it's ax squared plus bx plus c. B is in front of the x, so it's 10. So we add 10 over 2 squared to both sides. And don't worry about the signs. When you square them, it becomes positive anyway. On the left side, only do the inside of the parentheses. Don't square it. So we have x squared plus 10x plus 5 squared. On the right side, work it out all the way. So we have negative 23 plus 10 over 2 is 5 squared. Negative 23, 5 squared is 25. 25 is bigger, so it's positive. 25 minus 23 is 2. So we have x squared plus 10x plus 5 squared equals 2. Step 5. This is where you complete the square. On the left side, inside a parentheses raised to the power 2, put whatever's under the squared. So it's first term. So it's x. The first sign, which is plus in this case, and the last term, because that is we put under the square. Now, the beautiful thing about this part here, if you want to find the vertex from this step, if you want to find the vertex, set equal to 0. In other words, we have to move the 2 over. Move the number to the other side. So if we wanted to, we'd have x plus 5 squared minus 2 equals 0. This is the vertex form. So the vertex of this equation would be negative 5, negative 2. It's whatever's opposite inside there, and what is, it is. Or, here's another thing. If you were given the vertex form originally and you were asked to find the x-intercepts, put it in this form now. Move the number to the other side. Now we solve for x. So we're looking for the x-intercepts. Square root both sides. So we have an x plus 5 squared square root. Here's the important thing. It's called the square root principle. Whenever you square root a squared term, place a plus minus in front of the answer. In other words, if I gave you this, x squared equals 4, what can x equal? What could x equal to make it true? 2. So x can equal 2. Or x can also be negative 2, because negative 2 times negative 2 is also 4. So when I square root both sides, the square and the square root cancel, and I got a plus or minus square root of 4, which is a plus or minus 2. So whenever you square root something squared, put a plus or minus in front of it. Where I put plus or minus in front of this one. So the square and the square root cancel. So I have x plus 5 is equal to plus or minus square root of 2. Solve for x. Subtract 5 from both sides. X is equal to negative 5 plus or minus square root of 2. Those are my two x-intercepts. Negative 5 plus radical 2. X equals negative 5 minus radical 2. Those are our two solutions. That's why we do this instead. So that's to complete the square process. And that works best is if you have an even integer in the middle. Because remember, you have to take b over 2 squared. And if it's an odd number, you have fractions. If it's a fraction, then you have a bigger fraction. All right. The last method to find x. The third method is the quadratic formula. Since we just solved this one, this is fine. Remember, what we found for x was negative 5 plus or minus square root of 2. So the quadratic formula, here are the steps. Set equal to 0. In other words, everything has to be to one side. Label A, B, and C. So A equals 1, B equals 10, and C equals 23. Now plug it into the formula. This is the formula. Negative b plus or minus square root of b squared minus 4AC over 2A. And work it out. As I said, the quadratic formula is the method of preference to find the x-intercepts. All right, so let's do it. So we put it set equals 0. We labeled A, B, and C. So let's set them all. Here's the equation. Get in the practice of always writing down the formula. Whenever you use a formula, write it down in your equation. It'll help you memorize it, and it'll make sure you put everything in the right order. So in here, we have negative b. So 10, so it's negative 10. B squared, b is 10 squared. 4 times a times c. 2 times a. We plug them on there. Now let's work it out. On the bottom, 2 times 1 is 2. Negative. Inside the radical, 10 times 10 is 100. Negative times positive is negative. 4 times 1 is 4. 4 times 23 is 92. And good. Try to keep away from your calculators. Try to do this stuff on a piece of paper in your head. Exercise the brain, because really you don't do that during the day. You let the computers do all the work for you and you're typing. And so at least practice something. Negative 10 plus minus inside. 100 minus 92 is 8. We can simplify inside the radical. 8 is made up of 2 times 4, or 2 times 2. So it's made up of 2 times 2 times 2. Since it's a square root, there's a 2 there. Once you have 2 of a kind, that 2 of a kind can come out in front. Anything else stays inside the radical. So radical 8 becomes 2 radical 2. Look at the top. Can anything factor out? Does 10 and 2, do they have anything in common? 2. So I can factor out a 2 out of top. 10 divided by 2 is 5. The 2 is gone, so I have now you can cancel the 2's. And there's our answer. Same thing we got last time. If you have trouble with this part here, seeing what they have in common, what you could do at this point, you could split them both up. 10 divided by 2 is 5, so it's -5. The 2's cancel. And then we get that. You can do it either way you want to, doesn't matter. So we learn how to find the vertex. If it's in vertex form, if I'm give you if I give you this, what's the vertex? -4, -5. Very good. It's the opposite of this and that. We know in standard form, the y-intercept is the constant. What's the y-intercept of this one? It's not -5. Because how do you find the y-intercept? Set x equal to 0 and then solve for y. So we have 0 plus 4 squared minus 5. 0 plus 4 is 4 squared. 4 squared is 16. 3 times 16 is 48. Minus 5 is 43. So the y-intercept is at 0. So, and just put all this stuff together and practice. There are still, let me see. Two more sections solving. We should finish those next week because it's solving rational and radical equations, fractions and square roots, and then solving inequalities of absolute values. So those are just formulas and procedures. Okay, that does it for the day.